ITER ASTORUM, Episode 1, Return to the Moon. In the year 2030, the long conversation between Earth and the sky becomes a plan. This series follows that plan from its first practical steps to the day a human ship breaks into orbit around Alpha Centauri. We keep what is true: real physics, real chemistry, real biology, and real engineering trade-offs. We will move decade by decade, from near-Earth space to the Moon, to Mars, to the outer system, to interstellar precursors, and finally, to the first crossing. Our journey begins where it must: the Moon. It is Launch Eve in Houston. The mission: Artemis IV. The goal: deliver the human landing system to lunar orbit. NASA will bring Orion and its crew to the Moon. SpaceX will bring the specialized Starship that will land them. This Starship has no heat shield, no flaps. It will never return to Earth. It exists for one purpose: to take people down to the Moon and back up again. The architecture is complex. Multiple Starship tanker launches in low Earth orbit, cryogenic propellant transfer of liquid methane, and liquid oxygen. The lander's journey to a special halo orbit around the Moon. Orion arriving separately. Docking for crew transfer. Descent to the South Polar region, and return to orbit. Each arrow in this plan hides a dozen critical decisions. Raptor engines burning methane and oxygen. Throttle control tuned for 1/6 gravity. Solar arrays and fuel cells sized for days, not hours. An elevator long enough to carry suited astronauts down a 50-meter hull. And perhaps the most delicate part since Apollo: docking two ships built by entirely different teams. Inside Orion, 4 astronauts are on their way to the Moon. 2 will descend. Commander Diaz runs through the checklist: suit checks, life support packs, communications. "Let's keep it boring," he says. Mission Specialist Park grins. "Copy boring, but let's make the geology interesting." They have trained for partial gravity, practiced with simulated lunar soil that clogs every hinge and zipper, studied the low sun angles at the rim of Shackleton crater, where ice hides in permanent shadow. Their tools are precise: a compact drill, a mass spectrometer for analyzing lunar volatiles, a paper-thin seismometer plate, and a small ISRU demonstrator. If we will live off the land beyond Earth, it begins by pulling oxygen from rock. The approach to the waiting Starship is slow and careful. The lander is white, smooth, its high-mounted thrusters framed by tall solar wings. "Orion, you are go for final approach. Range, 30 meters. Diaz replies, "Copy go." Translating. Navigation is by LiDAR and optical marks. The docking ring is built to Orion's standard. No tricks, just millimeters of alignment and patience. A metallic clack marks soft capture, then hard. "Capture confirmed," comes the call. "Welcome to your ride to the surface." Inside the tall, utilitarian cabin of the Starship lander, ladder rungs run the length of the interior. A lift platform hums, traveling the shaft and returning. Lunar dust is like ground glass, and the elevator will meet it. Filters line the airlocks. Suit ports reduce how much dust gets inside. Every tool, switch, and handle is sized for stiff glove ergonomics. The descent begins. The Starship rotates, pitches, and its engines ignite with tight blue-white flames. Altitude: 3.2 kilometers. Velocity: 120 meters per second. Landing is momentum management. Gravity is weaker here, but fuel margins are not infinite. High-mounted engines reduce regolith blowout. Throttle is gentle to avoid digging a crater beneath the pads. Radar altimeters and optical navigation cross-check down to meters. Dust plumes spread low and wide. The ship settles on long landing legs. "Contact light," Park calls. "Engine shutdown," says Diaz. Silence. From Houston, HLS, Welcome to the moon. The suits pressurize. The elevator lowers the astronauts to the surface. The sun skims low along the horizon, casting long shadows across a gray and brown landscape. Diaz radios. 1/6 G feels like cheating. Copy, says Houston. You are go to deploy seismometer. Park plants a thin disk and extends its booms. It will listen for microquakes and meteor impacts, mapping the moon's interior over time. Nearby, a shallow trench is cut by a small auger. Park checks the readout. I am seeing a water signal above baseline, she reports. Also, carbon dioxide trace, recording. Ice is the reason for coming south. In cold traps, temperatures sink to mere tens of Kelvin. Water ice mixed with dust can become air and fuel. Electrolysis yields oxygen for breathing. Hydrogen can be stored or combined to produce methane. At first, carbon comes from Earth, but in time, it could be pulled from lunar rock. Near the lander, a microwave-sized machine hums. A small stream of oxygen bubbles through a capture loop and condenses into a sample ampule. From Houston, oxygen production confirmed at 7 grams per hour. Small breath for a machine, Diaz says. And a big step for our logistics spreadsheet, Park adds. They plant a mission flag, not as a claim, but as a marker for a work site. Apollo proved it was possible to visit. This mission is about staying, testing power systems and thermal management for the long lunar night, dealing with dust, proving the economics of permanence. From here will come a depot at the gateway. Foldable nuclear power units. Training for Mars, in a place that does not forgive mistakes. The astronauts look up. Earth is a thin blue marble against the black. Episode 2 will cover the infrastructure to make a base, cargo landers, sunlight mirrors at crater rims, and rovers that can survive the cold. The real journey to the stars begins with inventory, power budgets, and patience.